Sure, sure. Anyway, I'll be in India. I'll take care of it.
Oh, yes.
I'll give my India number. Okay. Good. So right now, what we will do, we will continue with the OLAP, continuation. So what we did yesterday is basically we kind of went through what is OLAP, right? So we know the two different, the functionality of the OLAP. We know what are the types of OLAPs, then relational, the architecture of relational OLAP. So the business objects, Cognos, MicroStrategy, SSRS, all of this, we can consider it as a little bit of our OLAP. Especially SSRS is not an OLAP, but it is more of a reporting.
I wanted to just ask that, can we just repeat a bit about the MOLAP?
Yeah, we can do that. Right, so in the OLAP, you saw that architecture, how does it look, right? So here, whenever you write a query, it automatically, the SQL goes to the database, it comes back. Now, in the architecture of MOLAP, you have data warehousing database here. Then you have analysis, Microsoft Analysis Services, right? Where you are actually importing the tables, what you want to build your cube. So once you specify these are all the views I want, and then you will also specify your hierarchy, so which is your parent and which is your child and so on and so forth. Then, you build a cube. So when you build a cube, it physically stores the data in a server, which is basically what we call it as multi-dimensional databases. So here, this Oracle or SQL server is called as what? Relational database management system, whereas these cubes are basically sitting it as an object. Each cube is considered as a database. So we consider it as a multi-dimensional database. So you can have as many cubes as possible in your server. And again, it is based on how much memory you have, how much of hard disk you have, and so on and so forth. And anytime when you are running a query against MOLAP, it has to be what we call it as MDX, multidimensional expressions. So the advantage of MOLAP is fast, right? You get the data very fast. But what is the disadvantage? It is not live, meaning there is a frequency of change, refresh has to happen on the cube.
Yes.
If the refresh happens on the cube, then the data is current, but we cannot guarantee that the data in the cube is always current.
Okay.
Because there is no way the cube will know what happened in my database.
So that means just data warehouse has the load which is going on through the ETL and from the source to stage and stage to transformations. Then we have the ETT, then we load to the data warehouse. On the analysis side, from the data warehouse, so they will have their own separate databases for the cubes?
Yes. The cube itself is a separate database. I don't know whether you know the architecture of, SSAS. SSAS itself is a box.
Yeah, it's a box.
Where it will build a cube. And that cube is called as a multi-dimensional database, MDDB we call it as. And if you are considering cube, if you see in your company you have cubes, so you can consider that cube as a data mart.
So then, what is in between the data warehouse and the MOLAP cubes in the Microsoft Analysis Service?
Your data. See, it's a yesterday we talked about, right? In a data warehouse, say you have 5 years of data. Okay, which is raw data available in your tables. In my cube, I want only 15 quarters of data. Right? There is a difference already, right? Here, the data in your data mart is sitting in RDBMS, which is in tables and joins and all that. Whereas when you build SSAS, it is one cube where it makes your analysis faster. That's the only difference.
My question was that, Rajesh, that yes, in the star structure we have the data warehouse, let's say for
Yeah.
my example is that for the compass only. So we have the compass,
Mm-hmm.
two facts and certain dimensions we have. One is the use fact, one is the sale fact, and then we have certain dimension that is sitting in the data warehouse. So for
Yeah.
building the cube, are the cubes being built directly onto that with the filter saying that we want this sort of data only? So
Yeah.
when they pull out the data, they store it into a table somewhere, similar structure table,
Not
or
in
they
the table. Not in the table. This is not in the cube format.
in the cube
That is
format.
why it is called as multi-dimensional databases.
Mm-hmm.
So the data in your data mart, which is in your star schema, is stored in table concept.
Mm-hmm.
The data in SSAS is stored in cube concept.
Mm-hmm.
That is the difference. That is why you have to, internally you have to write MDX queries to pull the data from SSAS because it doesn't understand the SQL part of it.
Hmm.
So, in a way, the storage mechanism in SSIAS is very different than the storage mechanism in RDBMS.
Mm-hmm. So that let's say 15 quarter of data came into through the MDX queries, and it is
To the
stored
cube,
there in
to the cube, to the
through
cube.
the queue. So what that is
Yeah.
what I'm trying to understand. What is this in blocks between data warehouse and the cubes?
That is basically an architecture where you use the tool. So you have to tell what is the
Okay.
metadata for
Okay.
this, right?
Mm-hmm.
Like SSA is cube designer. So that is what you are. So this is these two boxes, what you see that Microsoft Analysis Services, BI
Got it.
metadata, cube definition, and OLAP cubes are in the same box.
Got it. They are in the same box. Okay.
They're in the same box. One is from a design concept, and the second one is from the output concept.
Output concept. Got it. Got it. No, that's the only point
Okay.
I was confused about. I'm okay. Yeah.
Yeah, yeah. Okay, so that's what your architecture of OLAP is.
Yeah.
Now, when it comes to the cube, so now this one will actually clarify most of your doubts, right?
Mm-hmm.
So now when you really look at this one, so what does a cube really mean from an external world perspective, right? So here we are talking about a cube is a multi-dimensional structure of data. So now you put a table next to it, it is two-dimensional, whereas a cube is a multi-dimensional structure.
Yes.
Cubes are defined by set of dimensions and measures. Okay, these sides, what we call it as dimensions, and the intersection of this dimension is called as a measure. Okay, so now that is what a cube definition is. Okay, you can visualize a cube where you have four sides. See, that is the amazing part of the cube physical way. You and me, we worked with cubes where we have 6 sides. Whereas in technology world, I can have minimum 2-side cube to all the way up to 164 dimensions. Okay, so you can make it so complex or you can make it so simple. So it's based on how complex your data is and what kind of analysis you do.
Okay.
Now, what is a dimension? It's a structural attribute of a cube that acts as an index for identifying values within multidimensional array. Now, if you really look at it, this part of this cube, right? So you have 1, 2, 3, 4, 5, 6, 7. Okay. So these can be your customer dimension. Okay. This is what I'm showing. And this can become your product dimension. And this side can become your time dimension. So your walls of the cubes are made by dimensions. Okay. Now, this is what I'm showing. That here you have location, you have products, and you have time. So like this, you can have as many dimensions as you want in a cube. Now comes your data points, right? So now each one of the box on this side belongs to one location. We call it a cell, and here there is another cell, and this is the time. So Jan, Feb, March, April, May, up to whatever way you want it. So what are measures? The measures are numeric data of interest. So now I want to know in April how many apples we sold in China. So all you have to do is take this April cell, take this Apple, take this China, and these three will intersect at one point in time because it's a cuboid. Right? That intersection value will have a metric. So the more metrics you have, the cube size becomes bigger and bigger. Okay, so conceptually you have to visualize this. There is no way you will be able to open something and see, because this is how the conceptual model of cubes works. So the sides belong to dimensions and the intersection of those values belongs to the metric.
Yes.
So that is why in many companies we even call a star schema itself as a cube. Logical cube. They call it as logical cube, not physical cube. So your multidimensional analysis comes because of that particular thought process.
Yes.
Okay, that's what the cube is all about. So when it comes to the meshes. So now you can ask me any questions. Now you take your company as an example, right? In the time it makes sense for you. Okay, instead of location, you can make it as a transit
points.
Okay, instead of products, you make it as customer.
We can say products also, because we have compass cards. We can say we have tickets, and we have the different category for this.
Then nothing like that. So now you can consider that as the tickets, right? So you have card, you have ticket, you have gift card. I don't know what are all the others.
Passes, university passes, student passes, monthly passes. So different product line is there.
That is good. So I want to know, in the month of April, in the transit, New York 42nd Street, I want to know how many tickets I sold. So all I have to do is go to April, go to New York City 42nd Street, and look for tickets. These three intersect will have a number. And that number, you read it. So it is kind of an SQL only, but the language, what we call it as, is an MDX in the cube world. So that's how the technology helps us to retrieve the data much, much faster. So if somebody asks what is a cube, what I do? It is pre-aggregated. We aggregate the data at various levels. You can aggregate the level at April. You can aggregate the level at 1st of April 2015, or you can aggregate the data at a quarterly level or monthly level or yearly level. So what is a cube? A cube contains pre-aggregated and pre-calculated data. It's already calculated, so you don't need to calculate right now. Whereas in RDBMS, you have all these records available everywhere in those tables, right? So you can write a query, but when you write a query, it has to join those tables, right? Number one, it has to apply the filter. Okay, then it has to apply the group by. Now all of this happens and you are waiting at that particular point in time. Even if it takes 2 minutes, you are still waiting and the computer is doing that work in an OLAP environment. In an MOLAP environment, because the data is available at a different aggregated level, it doesn't need to do join, it doesn't need to do a group by, but it does still have to do a filter.
So how the group bys are already defined? What number of group bys?
Yes. Yeah, that's based on your hierarchies, right?
Can we have an example, like just one example?
So, in your location, you can have, what is your lowest level in your location?
Lowest transit points.
Station, right? So transit point is your lowest location. What is your highest location?
So highest location, country.
Or a state. We'll take state, because if you're working for country,
it will be province, province,
Yeah, province, right? So one province has multiple,
cities.
Province, cities, zip codes, and transits. Okay, so if you take an example of location, you have province, then you have city, then you have zip code, then you have transits. So now the data is available at a transit level. It is also available at a zip code level. It is also available at a city level, as well as it is available at your province level. So when I drag and drop, like yesterday in business objects, I dragged and dropped, right? So similarly, if you just do a drag and drop your province, you will see the 4 provinces just like that. Now, whenever you say ticket sales, it doesn't need to do an aggregation because it's already aggregated in the cube at that level.
Yeah, that's what my question was. Aggregations, who defines that? Which type of aggregations we need? Is a user?
No, not user. It's the designer. So when you are building the cubes, right, you will tell what is the aggregation level you want, which can vary from 0 to 100%. If you say 100%, your cube building process will take more time and it needs more space. So by default, if I remember right, based on the work I did a long time back, around 30% of aggregation should be good enough on a cube. Then the remaining 70, it will calculate in the memory itself. But the cube, why cube becomes faster is the required data is already available in a way you are consuming it.
Yes, you're not sorting, you're not summarizing, you're not doing any
you're not
aggregation.
joining. The main problem is joining.
Yeah.
And then you're doing a group by. That's going to consume a lot of time when you have millions of records.
Lots of I/O in that, yes.
Right. So that is the only reason, Microsoft SSAS is still surviving. Otherwise, nobody would have been touched it. That was the only product they had very good from my perspective that nobody was able to compete with it. SSAS cubes, right? So I worked on Teradata environment where we pulled the data from Teradata and we built the cubes. And we did not use SQL Server data warehouse, but we used SSAS cubes alone in our data warehousing environment.
Wow.
Because my end user want to just look at the data through an Excel. Now you can just expose the cube with an Excel and my end user is very happy.
Yeah, they can do slicing, dicing, anything they want.
Anything you want there, you can do it, right? And they're comfortable with Excel, so they're pretty happy. All right, so they can build something and they can do a refresh. All that they're able to do it.
Yeah.
Okay. Is it making sense?
Yes, does make sense.
Okay. So that is basically, it just gives you the idea of how the cube looks like, and these cubes can be exposed to your end user through your front-end applications, like Excel, Power BI, or business objects. So from whichever tool understands the MDX queries and OLAP connector, you should be able to do that. So people usually write queries based on .NET, and they actually pull the information from the cubes as well. So whenever you are developing reports, there are 2 aspects you have to look at. If you are developing a report, you have to understand where is your data.
So Tableau also can work on top of cubes?
I think so. Tableau has a connection to cubes, if I remember right, but I cannot guarantee that right now.
Yeah, because what I heard, I went to one of the conference, they said, they themselves said, the reason I don't know, they said Tableau's performance on cubes is worst. So they don't
yeah, so yes and no, right? I don't agree with that logically, because if you are pulling even again, you think about all of this, right? If you are accessing data from the cube to what we call it as Tableau is going to do more work, right, over and top of what you already put effort to build your SSAS. So you're not going to gain a lot of advantage from a data processing perspective, but from a visualization perspective, you gain the advantage. But the problem is you are going to double dip your data. You are going to store the data twice, one in SSAS cubes, and again you are going to store it in Tableau also, which is not adding a lot of value.
it might be the business strategy to saying to the customers that use directly the Tableau than using the cubes.
Yeah, see, sometimes what happens is if you're already built 18 cubes in your company, okay, and that everybody is happy with the data, and you bought Tableau today for visualization, it makes a lot of sense for you to just leave that cubes as it is and use that cubes data from Tableau, instead of redesigning it.
Yeah, if they're already built up there.
Yeah, it's already built and it is available and it is used and it is being used and it is, how do I say that? It's tested and it's managed properly. Everybody is happy right now.
True.
In a data warehouse, when you go to that level, right, where every end user is happy with the data, you're already, you already, how do I say, matured in that, data warehousing implementation. And you don't want to throw away so much just because you got a new tool. So you will see how both can exist together. Right?
So we can have the visualization also with the cubes?
Pardon?
Can we have the visualization also with the cubes?
No. Unfortunately, we don't have that from Microsoft. That is the whole issue, right? That is why they are coming out with Power BI and stuff like that right now. So what they used to do before also, you can build cubes and expose the cubes through SSRS. So SSRS can read data from cubes.
Yeah.
Yeah. So that's how you make your. If somebody says my SSRS report is very slow, it takes two minutes to run. One of the suggestions we used to give is just build a cube and pull the data from the cube. So that pre-aggregation, pre-calculation comes in and my performance increases automatically.
True.
Yeah. So it's all about combining various technologies to make things happen, Amit. Understand that.
I completely agree with you, but for me as a beginner, lesser experience, so unless you have experience, then only you can define which is best combination for on the user aspect point of view.
It's not the best thought process. It's more on the plug and play. What makes sense at that time.
Yes.
People see at the junior level you can't ask many questions, or sometimes you don't feel comfortable, or but the role actually forces you to do things differently in some scenarios. People will always ask an architect, what's going on, right? Why can't you build a solution for me with the existing tools? Right? So now, because you are asking more money. Right? So they are going to come back at you very hard on, you guys have so many tools, figure it out. So that's where your architect is going to figure out, okay, how do I link these two tools together so that I don't need to reinvent the wheel, or I want to save the time, or I want to increase the productivity.
True.
Yeah. So keep that options, so, and that comes only through a lot of studies, and you can't implement 8 different data warehouses in your lifetime, believe me. Right? So, because sometimes data warehouses get from the start to the end where it gets matured, it takes almost like 3 years. Okay, so you can't be part of SDLC of a data warehouse for your, entire thing. You step in, you understand something, you do your job, and you walk out. And somebody else will come and carry forward whatever you did.
Yeah.
Yeah. So that time, it becomes a little tricky to kind of understand, and that's where, I told you have to do the reverse engineering very, very effectively. Find out what you have, where is your source, how does all this knit together, how the data flows from one place to another place, So what is your data dependency diagrams, ETL diagrams, metadata information, reports, all that you keep looking at it. Every day spend at least 30 to 40 minutes to understand what is available there in your system, because data warehouses are huge by nature. Right? So
Sure.
Yep. Yeah. Anything else?
Okay. Would that be possible for you when you come back from India to work with me to help me do the reverse engineering for one of my data mart?
Yeah, I can do that.
Because I will do myself
No, no,
and I
you
will
have to
basically,
do it. No, see, this is
I,
what it is, right? I
yeah,
want you to try it with the knowledge what you have today. And
yeah.
when you start saying that where you started, what is your thought process, and
Mm-hmm.
when did you stop, where you are confused, and where did you
Hmm.
get stuck, right?
Yes,
Just
yes.
drop an email, then I'll be able to. Because what happens is the reverse engineering and stuff, it cannot be taught. The process can be taught, but the doing cannot be. You know what I mean? The hands-on, it is supposed to be done by you.
Yes. No, what I'm saying,
Okay.
I will start what on base of what knowledge I have, and wherever I
Sure.
stuck, I can drop you an email that I
Yeah.
am lost at this point.
Sure, sure. That then we will talk about how to make sense out of it.
Hmm.
Because anything where you get stuck also, then there is an open items. That's all. So if you close those, then automatically you will find a way out.
Yes. Okay.
Okay, it will take some time. But you need to have your own roadmap on how you want it to become familiarized and how much time you have. Then slowly you go one step at a time.
Okay.
Okay, so that's about the OLAP principles from the data warehousing perspective. Now, when it comes to metadata, right? So now we talked about so many various layers. Okay,
Hmm.
so when we talk about metadata, what does it really mean? So now on the left-hand side, you have the first layer, which we call it as source system layer. The
Hmm.
second basically comes your extract cleansing, and you take all of this data, load it into your create an optimization for the loader, and you have a data warehousing engine.
Hmm.
Then you have doing analysis. Basically you are doing either pulling the data out, and you are building the report.
Hmm.
Now this metadata layer actually connects all of these three together.
Hmm.
Okay, now I don't know whether do you guys in your company, do you maintain any metadata layer?
If you can explain me more about metadata, I might be able to
Hey,
say.
you joined your team. You went to the office for the first day.
Hmm.
Did they give you a portal where you can understand the data warehousing system?
Yes,
Okay, so that portal is basically what we call it as metadata information.
but there are just only
Okay.
PDF files there.
Then it is not a metadata system. If there are only dump of PDF files, it's just the user manuals or something, right?
Yeah,
But
it's
there
a
is no
PDF of
story
the
to
Word
tell.
documents there.
Yeah, so there is, then it is just a repository of documents.
Hmm.
So the metadata tells, what metadata can tell is, if you take a report which says that, a report on sales analysis,
Hmm.
okay, for transit sales analysis, for example,
Hmm.
then somewhere you should know without looking at your database structure, you should know what is the purpose of this particular report, from where this data is coming from, whether it is coming from SSAS cubes or whether it is coming from data mart directly. Because you can have a SSRS report, sometimes it comes from a cube and sometimes it comes from your database, right?
Hmm.
Okay, so now that is a simple example. If I don't have that, it means that I don't have metadata from a knowledge management perspective. Say
So,
you
so
you
that will
ran
be
an
a
ETL
document.
job yesterday.
That will
It's
be a
not only a
document.
doc. It's more than that. Even you can have documents, but there should be links between documents.
Hmm.
I'll be very specific. So yesterday you ran a job.
Hmm.
Okay. So it loaded data to your data warehouse. I want to know how many error records are available and what are those.
Hmm.
How do you do this?
Right now, these days, what we are, if let's say this kind of issue comes in that a job failed or something, what I have to do, I have to go into the first, the SSIS DB, that history where it failed. So I
Mm-hmm.
checked from that it is failed at what step, which table it was accessing, then go back to, we have another software, uh, I forgot the name of that software, which is, we use it for to analyze the data also. So we go there, but there is no document that we can look into.
Mm-hmm. Mm-hmm.
It is a manual process that one by step from the where it started and track back to the point where it failed.
Okay. So now, suppose it failed and it also generated some data points in your error log file, right? So how do you show that data? So I would like, morning I come and I will run a report which says yesterday these are all the jobs ran and these many jobs are successful and these many jobs were failed. Next to that failed, and I click on a button, I should see that error records.
Mm-hmm.
If you have that kind of an interface where it helps a person to know whether all the ETLs ran fine without writing queries, without actually going and looking various software tools and tools to understood what really happened, then it means that you are managing your ETL metadata very effectively. Using metadata, you should be able to know what happened in my system at any given time.
There might be there, but I'm not aware of.
Okay, there will be there, but it is not effectively utilized. Okay, right now you just said SSIS. You basically SSIS uses a default, a database in the database logging. You are using database logging in your implementation. So as a developer, you are going and querying that particular table to know what really went wrong.
Mm-hmm.
What we are saying is, in the SSIS package itself, you should be able to log those error messages into the respective table so that you can actually write a report against that particular table every day morning to see, how many error records and so on and so forth. If you are able to do that, then I can even say on an average there are 2 jobs which get failed every day out of 800 jobs.
No, we just get the email if it is failed. That's it.
You will get an email, that's all. But how do you tell your management saying that, okay, when I joined, there used to be 4% of jobs fail. Now I did so much work, now it's only 2% of the jobs fail.
No way.
Okay, so then your ETL metadata is not very good in your system. Because you don't know what's going on in the ETL. It's like, okay, I'll tell you, right? I have a database. I have 800 tables, huge database. If I ask what are all the tables you have, if you say, I don't know, I'll figure it out, then it means that you don't know how to manage.
That is the problem in my company. The 2 people who knows everything, they don't want to make this.
So now usually whenever you are learning these kind of things, slowly you figure out how to optimize it, how to make somebody else's life a little easier than yours.
It is a government organization.
That's okay, everywhere
you know the political factor for that.
Right?
The thing is that when I went to this one and there was one question about how many jobs are running on production and what is the business impact and what is the data impact to those jobs if they fail, and who are the responsible factor for that if the customer department has to raise a ticket, so whom they will appoint. It wasn't there. So then that task was given to me to list down all the jobs, run some queries and find out all the jobs running. But on top of the business responsibility, whom it will be, I don't know. So then I just given that sheet and to my manager, and my manager circulated to all the people who are responsible for the individual. They filled up. Takes a 1 month process, but then now they have the sheet. Whenever something fails or somebody calls to the customer for any job failure, So then because when the job failure happened, it goes to the customer department also. Then within the same time, they can raise a ticket to the right people, not to
That is
everyone.
good, right? So you are automating certain ability within your system to fine tune your error monitoring or managing the system better. Now, all of those information which helps to manage your data warehouse is called as metadata.
Okay.
Without metadata, you can still have jobs running, but the problem is nobody knows what's going on.
That's 100%
So
true.
the more the metadata you have, the better the control you have, number one. Number two, you can manage your data warehouse better. Now,
The
if I
process
ask you
control,
how many,
the process control tables which captures the log for when
that is
when
also called
the
as metadata.
it's also called as those we have.
Yeah, those are called as technical metadata. Okay, the other one what we talked is called as the usage metadata. How many times the job ran, how many times the job failed. Those are called as usage metadata. Usage metadata comes out of log file.
Might be DBAs are doing because we have dedicated DBAs for this.
Yeah. But if you're working in that an organization, you should be able to be transparent in that area when it comes to all of this, analysis.
Yeah, we just get an email from the production support that okay, this is failed. Now handle that.
Now you go and figure it out, right? So how do I automate all of those a little bit easier? So if I have metadata information, see, I know there are a lot of problems. What happens is a specific customer always gives wrong file. So now if my job keeps failing once in a week, right? And most of the times this, what we call that file, what we are getting from the customer is wrong. Or the format is, is not consistent. Then based on metadata, you can always say this job fails more than anything else. To find out the root cause so that we can avoid this pitfall in the future. So your metadata helps to fine tune your system in one way or the other.
Got it. Makes sense.
Okay. So that's what this entire metadata is. So the better usage of metadata, the better the system is.
Yes.
Okay. So it's very imperative for a data warehousing architect or data warehousing program manager to show what is the value you gave it back to the company in terms of how much of data you manage, how many jobs you run, how many failures you are getting, how many end users are using your reports, what is the business value. Because in data warehouse, right, nobody can tell I saved this much of money.
Can I take this call just a second?
Yeah.
Hello. Speaking. Yeah. No, it's okay. It's okay. Actually, yeah, I was in a meeting. If you can give me a number, I can call you back. Just a second. 604. So whom should I be asking for? Alan. Sure, Alan. I'll give you a call back. Just give me 10 minutes. Thank you. Hello.
Yeah.
Sorry, man.
Yeah. So that is what the metadata is. So the more the metadata we are capturing, the better it is for the data warehousing team.
Yes.
So this we consider it as one of the success factors for your data warehousing implementation. Okay.
Yeah. Okay.
So any questions you have on this?
No, I had a now very good view of what the metadata repositories, and definitely, actually, I'm noting down my points. When I go back, what are the things I have to look for?
Sure, I understand.
Yeah.
Okay.
Okay.
Yeah. So now
Mm-hmm.
You know what a data prof. So yeah. So now this is basically to give you an idea. So now I'll just talk about a little bit of BA requirements as such. Okay. So what exactly goes in when somebody says, okay, I'm part of data warehousing team. I collect requirements. How do I validate it? What are the SDLC process for data warehouse, so on and so forth. A lot of documentation you have to do in the BA space. Okay. Suppose if somebody tells me this kind of a question, right? So analysts should be able to do offline analysis using BA platform. This is just I'm throwing out something. Okay. Analysts should be able to do ad hoc query on the BA platform. We should be able to schedule reports so that the business user gets the reports on time in their email box. All the reports should run within 2 minutes, even on 4-year trend analysis reports. Okay, so if somebody tells all of this as the requirement to somebody, right, who can be a software company, or it can be a technical architect, or it can be a program manager. Now, how do we architect the solution? That's how it really boils down to when it comes to BA requirement. Okay, so now when it comes to the requirements, now this is just to set the stage. Okay, so there is no starting point, but I just threw this particular question so that we will get into the storyboard. Now, when you think about data warehousing requirements itself, right, because the nature of the beast is so complex, right, as the company is bigger and bigger, there are so many stakeholders you have to deal with. There's so much of data points you have to collect. So what happens is there are multiple ways you look at your requirements. Okay, so one, from the how do we put this on us, right? You have the data acquisition layer. So whenever I think about this one, right? So where I start as end user application. So what is that you're looking for? Which is basically given by your software requirement specification. Then you have technical architecture, which talks about what kind of tools and technologies you are going to use. Then you have dimensional model, right? So you are building a dimensional model for analysis. Then your program manager comes and talks about how to build this project, how many days it's going to happen, so on and so forth, resource loading, all that. Then you have the deployment, which is a migration process which happens from your development to UAT to production and so on and so forth. Right? Then you have a physical design of your database. Then you have the ETL data controls and stuff like that. Then you have maintenance and growth. All of these angles you have to discuss. So right now I put in what are all the things I think is necessary for me as part of the requirements gathering. But anything beyond this also can be part of your requirements gathering. So there is no set defined documents which you have to depend on. Sometimes you start with 10, but you will end up going up to 20, or you will stop at 10 itself, because this is more than enough for this kind of a complexity program what we are involving with. So when it comes to requirements, always think about 3 things, right? First, think about domain, what kind of domain it is. Second, think about how big the company is and how many subject areas they are dealing with. Okay, the third one is think about the technologies, what they are already aware of and what they are already using. Then you propose a solution. Okay, so now all of these will become an artifact for you to take a better decision for your company itself. Okay, so now what does your business requirements consist when it comes to data warehouse? So I gave a slide for that. So from the business perspective, they look at, what is my project drivers, or, sometimes they call it as charters also, right? Business objectives and needs, right? What is the goal of this business? So usually we build data warehouses because MIS takes longer time. So, if I want to do analysis, it's taking longer time. That's one of the primary reasons we will go ahead and build a data warehouse for us. right? And the user or customer requirements, what is the background, what is the value provided to your users, right? So then you have the vision, business case, with statements, So this is where you will clearly articulate your stories from the business side. Okay, so today I'm not able to analyze the customer on when this, types of the, okay, I'll tell you this problem, right? I am not able to differentiate a tourist versus a citizen who lives in this province, and what is their spend on my company. This is very relevant for your transit management. Okay. Now today, I just talked about it, but do you have data for this? If you don't, how are you going to deal with it?
Yes.
Right? Those are the kind of requirements you typically get from the business side, so that people can make those storyboards as the backdrop to define their data points, to define their data processing, to define their data analysis. There is a data acquisition, there is a data processing, and there is analysis. You have to think about all of these three areas when you see the business requirements. Okay, so then you have again, scope and limitations. You can, whenever you say business requirements, these are all the 5 or 6 different things I will be looking for. What's my business contact? What is my project success factors? What's my go, no-go decisions I should take? Because this is at a very high level what you are talking about, because it's all coming from the business perspective. Sometimes they call it as BRD, business requirement document. Okay. Then you have the end user and functional requirement. So what is the user requirement? So when you say user requirement, if I am the transit manager, operational, right? So you are going to call yourself a transit operational manager, for example. What is that I look for as an end user, right? So now when you go to, as a data warehousing guy, if you send a message to your transit operational manager, okay, boss, tell me what are all the 5 things you look for so that you can sleep at night properly. They will tell you, believe me. Right? Those are called as key performance indicators.
KPIs.
And we start there. Okay, like how you mentioned, one of your managers sent an Excel to so many people and they filled everything, right? So similarly, there is a charter which tells, okay, so tell me what are the 5 or 10 things you need to know every day and you are looking for today, and is it available? If they say, I am looking for this today, but it is available, but it is coming only tomorrow to me, not today itself. So there is an opportunity for you to add value. Or sometimes they will say, I wish I wanted all of this information, but it never comes to me. Right? So that's the user perspective. Okay, so that is the user requirements. When it comes to the functional requirements, you talk about technology. Okay, so from the user perspective and from a functional perspective. In the functional perspective, you talk about data, you talk about data management, and front-end user requirements, whether it should be, how to export it, how to do a search, how that function of that report actually performs. Okay, so then you have information requirements, implementation perspective, right? So you have information, you have interface, you have functional, you have, again, how the quality of the data is available. So why I am showing all of this one as any document what you see in your company will fall under one of these. Okay. Now, as you grow in an organization, you should be able to link all of these documents to see the bigger picture, Or if you know the bigger picture, you should collate all of these artifacts to see the detailed one. So that you will be able to guide people, or you will be able to execute your projects better. Make sense?
Yeah.
Yeah. Okay. So when it comes to the data system development and deployment and support, you know that system deployment, how you can do the communication between each one of the systems, training and support, ongoing user data and system maintenance. So this is just to give an idea of, what are all the various things happens in a data warehousing environment and how typically things going to look like. Okay. And the approach of implementing a data warehouse, it's in a very high level cyclical model. You do the requirements gathering, analysis, you validate, you logically build a model, physical model, you implement, you validate. Again, the new requirements comes in. So for me, your data warehouse approach is what I call it as a 4D approach. You have discovery, you have design, you have development, and you have deployment. And again, it continues. So the discovery never stops in a data warehouse world. So when a new initiative or a new program comes, again, you keep expanding your data warehouse as much as possible to gain the most optimized way of doing things.
Yes, that's true. That's true.
Okay. So for a successful warehouse, what we are saying is, you always keep your, user and builder together. Okay. Otherwise, you build a home where, either the architect doesn't like or the user doesn't like.
Yeah.
Okay. So it's an ongoing joint venture. Train the users one step at a time. Don't teach them data mining when they don't even know what is business intelligence. Consider doing a high-level corporate data model in no more than 3 weeks. Sometimes they will say 6 weeks, 6 months, I made to figure out what I want. Then it is not correct. Okay, so look closely in your ETL tools. It's very important because that acts as the 70% of the pain, okay, in a data warehouse world. Okay, implement a user-accessible automated directory to information stored in the data warehouse. This is basically what I call it as a metadata. Say today you went in. Okay, say I become an analyst in your company. I should go to a portal and I should say, I am so and so, my manager is this guy, and I want access to the subject area. And my the person who manages the data warehouse should get the email. He will get an approval. He will give the approval, and I am on the system, and I am up and running. That level of automated directory should be available in your data warehouse. Okay, determine a plan to test the integrity of the data in a data warehouse because data quality plays a major role in any implementation. Okay, so you always try to test the complex and exceptional scenarios. Okay, from the beginning, like the example what I gave you, right? So build take up a story and start thinking about how do I project this particular data to my end users. And that is very, very important. And if you are able to take a business problem and try to narrate a story through your data, you have the best data warehouse for that particular company. But if somebody says, I don't know, they should know why, they can say, I don't have data for you right now. That's okay, because people understand that. Sometimes business guys will come and say, what is this? What are you talking about? I'm running this business. I know this data is available because I use it somewhere, right? It means that we did not understand the systems better as an IT person. So it's very important for you to know the landscape of the existing applications and build a new system which can scale to multiple levels.
Yeah.
So this is just to kind of wrap up, the pointers on, what is the data warehouse and what are the top 10 things, what you can think of to build a successful data warehouse.
Yes.
Make sense?
No, I will reach to that point someday, but right now I'm just a learner.
No, that's okay. And I just want to get a feeler. That's all. I don't want
No, I
to.
agree. I agree. Yes.
Yeah.
Yeah,
So
that's very
this
good.
is what it's always. When you just listen, what you got is only 20%.
Hmm.
Okay. So the remaining 80%, it takes its own time.
It's a time that will take care. Yeah, no doubt about that. No, thank you
Okay.
very much, Rajesh. And
Yeah.
just one thing I wanted to say that the last 3 slides you showed, that is not in my slides that I have.
Yeah. I will send it to you.
Yeah, just send it to me those, and let me know what time today we can touch